welcome back to this installation of Chemistry 1, our favorite teacher's videos. This chapter is all about chapter 15, and that's water. So let's start off by talking about the liquid state of water. Okay, so remember from last semester when we did our Lewis structures that H2O, water, is a very simple molecule that has 3 atoms that are all bonded covalently. So they're sharing electrons. Okay, remember that oxygen is the electronegative one, and so it makes a polar bond between the oxygen and the hydrogen, making the oxygen the slightly negative charged part and the hydrogen, both of them, each a slightly positive. Because of this slight charge in the polarity, the shape of water is a bent shape. Its molecular geometry is bent. All right. So just remember, when we have polar molecules, they're attracted to each other by dipole interactions, which means the slightly positive of one molecule will form a bond, a dipole bond, with the slightly negative part of a different molecule. This is not going between in one molecule, it's between many molecules, as we see right here. And so because this has hydrogen in it, we actually call this a hydrogen bond. And that's what holds water together. And that's what makes water so unique from different molecular compounds. So, just to clarify, many unique and important properties of water, including the high surface tension that it has, its low vapor pressure, and its high boiling point, all are because of the hydrogen bonding holding the molecules together to form liquid water. So, the first property we're going to talk about is surface tension. Have you ever noticed that when you have water spilled somewhere, it nearly forms spherical droplets, or like a hemisphere of a droplet? Okay, and this is because the surface of the water acts like a skin to hold everything in together. So, if you look up at the little bubble up here, the inside, the hydrogen bonds are formed to hold everything together on the inside. But on the outside, the surface, they don't have anything pulling on the top above them. And so they're pulled inward by the other hydrogen bonds. And this inward force is what we call surface tension, because it's reducing the surface area of the water droplet. And because of the surface tension, that's why water forms this way. So here are some pictures of different surface tension things. If you want to, you can try this one in our surface tension activity, where you have water and you place a paper clip on top of the water so that it sits on the surface of the water and doesn't sink. It's very difficult to do, but if you do it, that's pretty awesome. This one down here is a water bug that walks on the surface of the water. It is light enough that it doesn't break the hydrogen bonds holding each water molecule together, so therefore it can run across and scurry across the water surface. And then the last picture is just a picture of a water droplet in case you needed a visual of what we're talking about. So, more surface tension. All liquids have surface tension, but water's is higher than most because of the hydrogen bonding. This is why that on some surfaces, the water tends to bead up rather than spread out because of those hydrogen bonds. But it is possible to decrease the surface tension by adding what's called a surfactant. A surfactant is a substance that interferes with the hydrogen bonding between the water molecules and then reduces the surface tension. So therefore, it can't be that nice little hemisphere bead of water that we normally see. So if you look at the picture at the top, the left would be plain water, and it has its nice half of a sphere for its shape. But the one on the right is water with a surfactant. And if you notice, the surfactant really spreads out that water bead. It doesn't stay in its nice little bunched up shape anymore. An example of a surfactant that I use is whenever I wash my car, I always wipe down the windows after I'm done with a chemical that's called Rain-X. So when adding Rain-X to my car window, it acts as a surfactant where it will reduce the bonding in the water, and it will help the water droplets run off your windows a lot nicer. So when you're driving in the rain, it's a lot easier to see out of your windshield. And your family might do that too. Who knows? But that's an example of what a surfactant is. So another thing that hydrogen bonding is special for water is having a low vapor pressure. Remember, to have vapor pressure, we have molecules that used to be liquid and bonded together escape into their vapor state, and they have to have a high enough energy to escape into that vapor state. Because there's so many hydrogen bonds, this process is very typically slow in water. And because it's slow, that's why it has a low vapor pressure. Okay? It takes a lot more energy for the bonds to break and for it to completely escape out, because maybe one at the bottom breaks the bonds, but then as it's floating towards the top, it forms a new bond, and so then it can't break away. So that's why our vapor pressure is very low for water. And then the last thing that we're going to talk about today is the boiling point of water. Most molecular compounds that have a low molar mass are usually gases or liquids with low boiling points at normal atmospheric pressure, so like 101.3 kPa or 1 atmosphere. Okay, but water is different. Because of those hydrogen bonds, they prevent water from having a lower boiling point, because the hydrogen bond holds the molecules so tightly together that it can escape a lot better. So, all has to do with these hydrogen bonds today. Now, go ahead. If you are in the morning classes, we're going to do our surface tension activity now. Or if you're in the afternoon classes, go ahead and complete the water assignment on my big campus. And on Wednesday, it'll be switched. All right, I'll see you later.